Dear students, in the last session, we are discussed about the elementary operations on a matrices. So there are 6 elementary operations, out of which 3 are row operations and 3 are column operations. So first one is the interchanging rows and columns, interchanging rows or columns of a matrix. We denote that as row is interchange with another row. One row is interchange with another row. So this is first elementary operation. And the second elementary operation is any row is multiplied by a non-zero constant. K is a constant which is not equal to 0. So any row multiplied by a non-zero constant resultant in any other row or the same row. So this is second elementary operations. And third one, a row is multiplied by a constant k and add it to any other row resultant in either in Ri or in Rj. So these are the 3 elementary row operation. So corresponding elementary column operations is any 2 columns are interchanged. So Ci is interchanged with Cj. Any column is multiplied by a non-zero constant k resultant in any other column or in the same column. And third one column is multiplied by a non-zero constant k and is add to the corresponding entries of any other column resulted in a column. So these are the elementary operations. Now using these elementary operations, we find the inverse of a matrix here. I'll take one example here. Finding the inverse of this matrix 1 minus 1 2 3. 1 minus 1 2 3, we have to find the inverse of this matrix. So we know the procedure to find the inverse of the matrix. If we are using the elementary row operation, the first step is we write, let it be this is the matrix A. The first step we write is A is equal to I into A if we are using the elementary row operation. Remember that once you start with the elementary row operation, till end, to get the final answer, till end we have to use the elementary row operation itself. In the middle we won't consider elementary column operation. So here I am using the elementary row operation. So first step is A is equal to I into A. If we are using the elementary column operation, then A is equal to A into I. So we have to write the identity matrix after this matrix A. Okay. So this is the first step. So what is A? A is this matrix 1 minus 1 2 3. So this is the matrix A. And the identity matrix, here we are considering the 2 by 2 matrix, therefore identity matrix is 1 0 0 1 A. So the next procedure is we have to reduce this matrix to identity matrix by repeated application of elementary row operations here. That means 1 minus 1 2 3 should be reduces to 1 0 0 1. Simultaneous application of elementary row operation on this matrix, that will reduce us to one matrix B. That matrix B is nothing but inverse for the given matrix A. Let's begin here. So 1 0 0 1. So already 1 is there. No need to change this entry. So till end try to keep this entry as 1 here. Already 1 is there. Next, we have to change either this entry to 0 or this entry to 0. Either this is 0 or this is 0. Don't touch this one. If you touch earlier this one, then remaining entries get altered here. So either note this one or this entry. Now we'll consider this entry. So instead of 2, there should be 0. We are using the elementary row operation, therefore we have to consider row itself. Don't consider columns here. That means here 2 is there. 2. In the first row 1 is there. Answer should be 0. In here 2, in the first row 1, answer should be 0. That means if I multiply 1 by 2 and if I subtract, the answer is 0. Okay. So instead of 2, here I have to write 0. Therefore, this is entry of the second row and this is the entry of the first row. So 1 into 2 minus 2, the answer is 0. Therefore, 2 lies in the second row. So this is the first row and this is the second row. So 2 lies in the second row minus, I am multiplying a non-zero constant and 1 lies in the first. So this is this 2 to 0. The changes in R2 indicate that R2 changes, that is R2 minus 2R1. So write the elementary operation. Apply R2 gives R2 minus 2R1. Okay. Next, there is no changes in the first row, only changes in the second row. Write the first row as it is. 1 minus 1. Second row, R2 entry 2 minus 2 times R1, corresponding R1 entry. So corresponding R1 entry is 1. So the answer is 0. Therefore, instead of 2, we have written 0. Next, this entry. Every entry of the R2 gets changed because of this. So 3, R2 is 3 minus 2 into, what is the corresponding R1 entry? Corresponding R1 entry is minus 1. So minus into minus plus, 3 plus 2 is equal to 5. Okay. So this entry 5. So this is equal to, again here first row write as it is. In the second row, same elementary operation. What is R2 entry? R2 entry is 0 minus 2 times corresponding R1 entry is 1. So answer is minus 2. So this is minus 2. Next, this entry. R2 is 1 minus 2 times corresponding R1 entry is 0. You know that any number multiplied by 0 is 0. So 1 minus 0 is 1. So this is 1. 1, 0. Now I have to make this entry 0 and this entry 1. Now whichever may be easier, do that first. First I'll do this one. Instead of 5, I have to write 1 here. Okay, instead of 5, I have to write 1. That means if I divide 5 by 5, this becomes 5 divided by 5 is 1. That means how to write the elementary operation? Now changes in R2, because this lies in the second row, changes in R2. What is the changes? Entry of R2 divided by 5. So if I divide this entry by 5, that will gives instead of 5, 1. Okay. R2 gives R2 divided by 5. So again, first row there is no changes because the resultant should be in the second row R2. Here the elementary operation is R2 divided by 5. Okay. 0 divided by 5. We are not considering the first row here. So R2 divided by 5. So 0 divided by 5 is 0. 5 divided by 5 is 1 is equal to, again, don't consider the first row, right, as it is 1 0 minus 2 divided by 5 and 1 divided by 5 into A. So 1 minus 1 0 1. So these 3 over. Now this should be 0. Remember we are using row operations here. That means this entry should be 0 implies, how to do that? I have to make this entry 0 minus 1. The corresponding R2 entry is 1. Final answer must be 0. What is the procedure? These two numbers should be added. But we have to write the elementary operation, right? This minus 1 lies in which row? R1 plus 1 lies in R2. That gives 0. Where is the changes? Changes should be in first row. Okay. So this is the elementary operation. Next elementary operation. So apply this one. Now first row gets changed now. Okay. R1 plus R2. Sorry. 1 plus 0. Answer is 1. Therefore first entry is 1. Next. Minus 1 plus 1. R1 is minus 1. R2 is plus 1. Entry is 0. Only changes in R1. Write the R2 entries as it is. So 1 0 0 1 is equal to, here, R1 plus R2. R1 is 1 plus R2 is minus 2 by 5. This becomes 1 minus 2 by 5. What is 1 minus 2 by 5? That is 3 divided by 5. These are rough work here. So this entry is 3 by 5. Next, 0 plus 1 by 5. So this is automatically 1 by 5. So write the second row as it is, minus 2 by 5 and 1 by 5 into the matrix A. Okay. So repeatedly apply the elementary operation. The matrix 1 minus 1 2 3 reduces to the identity matrix 1 0 0 1. So this is nothing but I is equal to B into A. So B is nothing but A inverse, that is 3 by 5, 1 by 5, minus 2 by 5 and 1 divided by 5. One more. Finding the inverse of the matrix A is equal to 2, 1, 1, 1. Okay. Same procedure here. Here again I'll use the elementary row operation to find the inverse here. What is the first step? We write this as A is equal to I into A. The matrix A is 2, 1, 1, 1. is equal to identity matrix 1 0 0 1 into the matrix A. Now again repeatedly application of the elementary row operation, this should reduce us to the identity matrix A. We can apply the third elementary operation as well as first elementary operation to make this entry 1. First we have to change this entry 1, then either this 0, this should be 0, at the end this entry should be 1. Remember, this is the way. First make this entry 1, then either this entry 0 or this entry 0. After this, if you do this one, then third step is doing this entry 0 and the fourth step is doing this entry 1. Follow the same step here. So if you interchange these two rows, row 1 and row 2, instead of 2 we'll get 1. Okay. So I'll apply the elementary operation. What is the elementary operation? Row 1 and row 2 are gets interchanged. So entire row 1 and entire row 2 gets interchanged. That is, first I'll write the second row as the first row and first row as the second row here. 1 1 2 1. So that's equal to, you have to apply the same elementary operation to right side of this also. 0 1 1 0 into A. Okay. Now this is 1. Either make this entry 0 or this entry 0. Now we'll make this entry should be 0. Same procedure. In row 2 there is 2. And corresponding row 1 entry is 1. If you apply some addition, subtraction or mathematical operation, the final answer should be 0. That means you have to multiply 1 by 2 and subtract. Okay. Now check. 2 lies in R2 minus 2 into 1 and is in R1. Therefore, changes in, where is the changes? Changes should be in R2. Therefore, the elementary operation is apply changes in R2. What is the changes? R2. First row, write as it is. In the second row, the entries get changed here. That is, R2 entry is 2 minus 2 into R1 entry, corresponding R1 entry is 1. So this is 0. Therefore, this entry is 0. Again, R2 entry is 1 minus 2 into corresponding R1 entry is 1. So 1 minus 2, answer is minus 1. So this is minus 1. So this equal to, again, first row write as it is. In the second row, the R2 entry is 1 minus 2 times the R1 entry is 0. 1 minus 0 is 1. Answer is 1. So this is 1 here. R2 entry is 0 minus 2 times R1, corresponding R1 entry is 1. Therefore, this answer is minus 2 into A. 1 0 0 1. That means this entry should be 0 and this entry should be 1. Before doing this entry 0, I'll make this, okay, we'll do this entry 0 now. After that we go here. Okay. If I add these two, if I write resultant in this place, this entry become 0. Okay. Therefore, how to write the elementary operation now? The elementary operation is 1 and here minus 1. If I add these two, you will get the answer 0. 1 lies in R1 and minus 1 lies in R2. Changes should be in R1. So R1 gives R1 plus R2. Okay. What is the matrix now? First row get changes here. 1 plus 0. R1 plus R2. So 1 plus 0 is 1. 1 minus 1 is 0. And write the second row as it is. So that's equal to 0 plus 1, 1. 1 minus 2, because we are adding these entries. 1 minus 2, answer is minus 1. Write the second row as it is. Is this an identity matrix? No, because 1, 0, 0, minus 1 is there. So to make minus 1 to plus 1, what is the procedure? Minus 1 to plus 1. If I multiply minus 1 by minus 1, this becomes plus 1. Okay. Minus 1 that lies in R2 multiply by minus 1. Therefore, changes in R2. What is the changes? Multiply second row by minus 1. So, the first row as it is 0 and the second row is multiply by minus 1. 0 into minus 1 is 0. Minus 1 into minus 1 is plus 1. So that's equal to, here also first row write as it is and second row is multiply by minus 1. 1 into minus 1 is minus 1. Minus 1 into 2 is minus 1 into minus 2 is plus 2 into A. So this becomes I is equal to B into A. Therefore, what is B? B is nothing but A inverse the matrix 1 minus 1 minus 1